Okay, we've spent quite a bit of time talking about graphing linear equations over the last 2 days at home. So I just want to kind of formalize some of the observations that maybe you're making that I've asked you to kind of consider. So let me just generally talk about linear equations. So there's different things that could happen with a linear equation. One thing is, well, let me just draw a couple here and then we'll talk about them. All right, so the first thing is we read a line just like we read a book. We start from the left and we go to the right. So if you imagine yourself being on this line, one thing we would describe about the line is what happens as we walk from left to right. All right, so if you were a person on this line, we would say this line is increasing or rising, right? If you were to put yourself on the left of this line and walk to the right, we would say that it's decreasing or falling. If we were to put yourself on this line and walk to the left, walk from left to right, this does not increase or decrease. We would just say that this is a horizontal line. If I could spell here. Oh my gosh. H-O-R. Horizontal. All right, we'll talk about a little bit more detail about that one in this next one here. If you were to put yourself on the line right here and try to walk it, you would be plummeting to your death. This would not be good. All right? Just right. Right, that one's not good. Okay, so these here talk about the direction that the line goes, basically up, down, horizontal, or this would be vertical, but this again is not necessarily a good thing. There's another thing that we could talk about. You could be increasing, but you could be increasing ever so slightly, like this, or you could be increasing like this. All right, this is like a nice leisurely walk in the park. You're just kind of, walking nicely, but you're increasing. This is like you might need to get out your climbing gear for this one, or there might need to be some ropes to help you get up that. All right, this right here, these are both increasing, but the changes that we see then in here is we would refer to as steepness. Right, and the word that we use in math for that is the slope. All right, let's talk about this one. Again, this could be a walk in the park, just a slight decrease versus a really super steep decrease. And again, that is a change in the slope, that steepness that we would see from going like this or going like this. All right, so I always tell kids that when we used to live in Westchester, when Mr. Taylor and I first got married, we had a set of stairs that went upstairs, and they went like this. They had a very low rise and a long run right here. Low rise and a long run. A low rise and a long run. And they were wonderful stairs to walk up. In our current house, it's mostly one layer, but we do have steps to the basement, and right now it is a steep rise and a short run, and a steep rise and a short run, and a steep rise and a short run. So it's much less comfortable to walk up these stairs than it was to walk up these stairs, right? So when we talk about slope, that's what we're doing. We're comparing how far does my foot have to go up to how far do I have before I get to the next spot where it rises. So this vertical direction is called the rise, and this right here is called the run. Right, the rise. I'm in Abby's room, and I'm guessing you can hear that. The heater just kicked on. Oops. Sorry, it'll stop in just a second. When Abby was little, she always used to cry and say, "The heater, the heater." All right, the rise and the run, the rise and the run. So right here, the rise is much smaller than the run. Here, our rise, it's much larger than our run. All right, so this is an uncomfortable climb, whereas this is a very comfortable climb. So like, let's say, for example, if we were to do this, let's say this is a rise of 1 and a run of 3. 1, 2, 3. It's about 3 times as long as that. The rise of 1 and the run of 3. The rise of 1 and the run of 3. The rise of 1 and the run of 3. When we talk about slope, we write it as, we write it as the rise over the run. All right, how far is our y value changing, our up and down direction, compared to how much is our x changing? So it's the rise over run. And in this particular case, the rise is 1 and the run is 3. Right, so again, that's a very nice slope. It's a fractional amount, it's pretty small. But here, I'm going to go with the rise is 3 and the run is 1. The rise is 3 and the run is 1. The rise is 3 and the run is 1. So the slope for this would be 3, the change in the vertical direction, over the run, which is 1. Right, so again, slope describes the steepness of a line, and it is rise over run. But then there is the direction that I alluded to here. This is an increasing slope, and this is a decreasing slope. And again, I'm trying to get you to figure this out based on the equations that we graphed before. When you have an increasing line, like let's say you had one of the ones that we looked at was, let me go back to the videos you watched on Tuesday, y equals 2x plus 3. Hopefully you noticed that it was the sign of this, that number in front of the x, the coefficient, that caused it to go in this direction. And then the sign on ones that went like this, like the other one we had was y equals negative x plus 4. Anytime the coefficient of the x was negative, we ended up with a decrease, right? So let's kind of summarize some of the stuff here. Slope is the rise over the run. I still haven't told you where that comes from, though. The direction, it could be increasing or decreasing. We're going to see. We'll put this all together in just a second. The other thing I asked you to figure out was, where does it cross the y-axis? And again, for one like this is the very first one that you did on your first video that you watched on Tuesday. The first practice one, not the instructional one. But hopefully you noticed that this thing that was added or subtracted on the end was where it crossed the y-axis. So in this case, and when it crosses the y-axis, we call that the y-intercept. All right, so what is the y-intercept? That's what we're asking for when we say, where does it cross the y-axis? So these three things are the basic components of a linear equation. What is its slope? All right, how far does it rise compared to how far does it run? What direction? Is it increasing or is it decreasing, like that? And then where does it cross the y-axis? In other words, what is the y-intercept? All right, so let's look at this y equals 2x plus 3. Right, this is positive. I don't usually write it, but I'm going to put it right here for a second. That means this is increasing. This right here, we're going to say is the y-intercept. Right, and then the only thing that we haven't really talked about is this right here. And I'm going to ask you to go back and look at all the ones that we've done so far. And notice that this was the change in y over the change in the x. All right, and that is another word for slope. All right, the rise is the change in the y value because it goes up and down, and this is the change in x, or the run, because it goes in that direction. Now I'm going to put some of these sheets back here for us to see that. right? So again, remember how I wrote all these things along the margin? This was the change in x. It was increasing by 1. That's the run. That's going to tell us how much we're going each time left or right. And then this talked about the change in y. Each time we moved up, or each time we changed our x value, how much did our y value change? It always increased by 2. So if we talk about the change in y, or the rise, over the change in x, or the run, then we get 2, which is this number right here. All right, if we do the same thing here, we talk about the change in x, that's the run, or the number on the bottom, and the change in y, the rise, that's -1, and we end up getting -1, which is this right here. And this next one, we talk about the change in x, that's the run, and that goes on the bottom, that's 1. And the change in y, that's the rise, -2, and we get -2, and that shows up right there. Here, this one was unusual because the change in y, the change in x, the run, was 2, and the change in y was 1, and we get our 1/2 there. These are the ones that we just did today. Right, this one's a little bit tricky here because the x comes first. I'm going to rewrite this as -2x plus 5. Right, we look at the change in the x values. That's the run, and it goes in the denominator. That's 1. And the change in the y values, that's the -2, or the rise, and we get -2, which is that coefficient of the x. This one's going to be a little bit more obvious here. We talk about the change in the x, or the run, that goes in the denominator, and then the change in the y. Whoops, sorry, this shouldn't be a -4. It should be a 4, and then this is -3, right? Every time the x goes up 4, the y changes, or every time it goes either direction, left or right, 4, the y goes down 3, right? Which is the same thing that we have here. All right, this other one here, the change in x, the run, is 2, and the change in, here we go, the change in y is 1, and we get 1/2, which is that. All right, and this last one, the change in x was 1, that's the run, that's the denominator, and then the change in the y is the rise. Again, think of that, y has kind of an I sound in it, rise. All right, so this is -3 over 1, or -3, which gives us that. So this coefficient of the x is always going to tell us both the direction, right? The sign is going to be the direction. This -3 means it's going to be decreasing. This is going to tell us about the slope, right? 3 is the same thing as 3 over 1, so we can see our rise and our run here. And then this -2 is going to tell us where it crosses the y-axis, right? So this crosses the y-axis at -2. All right, so how can we use that? Let me just do another one right here. We're still going to keep plotting points just to get practice with it, but I do want you to see why that would be advantageous to know those things about it. So let's say I had an equation that said y equals 3/5 x minus 1. Right, well, the first thing I notice is that the sign of that is positive, and so I know it's going to be increasing. That means that as I read from left to right, it's going to go up like that. This is going to tell me how it's going to go up, right? That's the slope. And again, this means this is the rise, right? It's rising up 3 every time it runs 5. And then this tells me where it crosses the y-axis, or again, the y-intercept. So without even plotting any points, or without even making an xy table, I can say, well, the first thing I know is it's going to cross right here at -1. And the next thing I know, and I need to put some tick marks on here, Okay, the next thing I know is from here, from any point on your graph, to get from one point to the next, I have to rise 3. Again, that comes from that. 1, 2, 3. And I have to run 5. 1, 2, 3, 4, 5. And that should be the line right here. Now let's just confirm that by making a table. I'm not going to make the whole table, but I'll pick 2 values. I'm going to pick 0 and 5. Why am I picking 5? Because the 5 in the denominator here will cancel out with the 5 that I chose. All right, so our pattern is 3/5 x minus 1. So when I have 0, I'm going to do 3/5 times 0 minus 1. 3/5 times 0 is 0, and minus 1. That gives us -1. That's exactly what we got right here. And when I do 3/5 times 5 minus 1, 3/5 times 5, the 5's cancel out, so I end up with 3 minus 1, which is 2, which is exactly what I have right here. This is the 0.52. So without doing this, making our XY table, I can just read the information off of here and get the graph. All right. So, but again, I'm going to keep plotting because I want you to get practice with that. But I want you to, as you look at a graph, you should be able to tell me whether it makes sense or not. So for example, if I give you y equals -2x plus 4, and I say, here are a couple choices, which one is it? All right. Without having any information, you should be able to tell me the one that is most likely to be the correct graph. So first of all, we know it has to cross the y-axis at +4. Let me make this one a little bit better so it's actually a potential candidate. All right, so it can't be this one because this crosses at -4, not +4. So that's not going to be it. Can't be this one because it looks like it crosses, or it does cross at a negative number, so it's not going to be that. So then we have a choice of either it's got to be this one or this one because they both look like they cross at, well, they do both cross at a positive number. But then this one tells us that the line is decreasing, right? And so of the remaining 2, this has to be it because that's the one that's decreasing. This is increasing, right? So this information right here, whether we've got the graph or not, we can at least say, I'm expecting a line that looks like this. So if you happen to graph it incorrectly and instead you get this, you can look and say, oh, wait a minute, I did something wrong because it should look like this, all right? So we'll practice both methods, but again, it's kind of cool because it's keeping a lot of secrets right in there for us that we just have to use our detective skills to figure out how we can figure out what the line's going to look like even before we graph it. All right. Thank you. Bye.